17 and 18 because that's what I originally assigned y'all, right? And I didn't assign anything else, so if that's all you have or that's all you attempted, good. So these are both problems that you would see. All right, write the line of the tangent to the graph. All right, so the first thing is, if you want, you can say, well, what happens if we plug... Hey, look at that. You found each other in the hall. Thanks for bringing each other. Good seeing you. All right, so these are definitely the same type of problem that we had worked last time. Agree? AKA yesterday. All right, so we can figure out the point. We can just plug 1 in, so that's 1 squared plus 1 minus 3, which is going to give me -1. So that'll be my x1, y1. And then we want to find the derivative, so y prime is equal to 2x plus 1. How do I find the slope when I get to that point? See who was paying attention yesterday and the day before. How do I find the slope? Yeah, you're going to take that original x, plug it in right there. So you get 2 times 1 plus 1. So that's going to give me 3. So I have a slope of 3. And so using y minus y1 equals m times x minus x1, plug in what we know. So we got y minus minus 1, because that's our y value, so that would be a y plus 1, equals 3 times x minus 1. So that equation is our tangent equation at that given point to that particular parabola. All right, and then the second one got a little tougher. Why is the second one a little tougher? What's goofy about it? What's goofy about number 18? It is a fraction. I love it. And what else do you have in that fraction that kind of really starts getting silly? Square root. So this is the same thing. So the square root of x is equal to x to the 1/2. I want to bring that up, so it's going to become negative. So I'm going to wind up with 2x to the -1/2. Okay? If I wanted to figure out my point, we're going to take 4, and we're going to plug it in here. So square root of 4 is 2. So I wind up getting 2 over 2, which is equal to 1. So that's my point, my x1, y1. And then I want to find the derivative of this. So y prime is equal to 2 times -1/2 x, and then I'm going to subtract 1. If I subtract 1, that's the same thing as subtracting 2 over 2. If I subtract 2 over 2, that's going to take me to the -3/2 power. And that got a little, that just changed our thought process on this a little bit. All right, so what I would honestly do on this, rather than totally clean it up, actually, let's clean it up this way. This 2 cancels this 2, so I get y prime is equal to -x, but I can change that x because the denominator is a 2, that's a square root and raised to the 3rd power, and it was negative, so that's going to go underneath. So that's the cleaned up derivative, 1 over the square root of x to the 3rd. Then I can take that 4, plug it in here. So square root of 4 is, 2. 2 times 2 times 2 is 8. Okay, so I get 1 over 8, and that's my slope. I'll plug that into my y minus y1 equals m times x minus x1. So I'm going to get y minus 1 equals 1 over 8 x minus 4. And that is that. Okay, so collectively as a class, do you all think you could do a problem like that? Like on Wednesday? I think that's when I have to put the quiz till. Is that cool? All right, so let's go back a little bit. on the sheet and utilize this as some review. So if you recall, these were things that we had done prior to fall break, and then you guys all went and hung out in the graveyard and saw scary stuff and you forgot everything, right? All right. So 1, 2, and 3 across the top, you're finding what the y value is at exactly that point. So if I wanted to find f at -1, you go to -1, and it becomes that value. So that answer is just 1. If I wanted to find f at 3, I go to 3, and you find wherever the solid dot is, and that's going to be at 2. And then if I wanted to find f at 0, that's going to take me right down there, which looks like it should be -1. So that's the first thing. Those are not limits. Those are direct plug-in to figure out on the graph where the solid dot would exist. So the big goof up on here is if I get to -1 on the first one, is it the solid dot or the open dot? Well, it has to be the solid dot. That's where it exists. The graph doesn't exist at this open dot. That's the same thing here. If you go f at 3, you look for the solid dot, not the open dot. If you have an open dot, it does not exist. Okay, if there was only an open dot there, it wouldn't exist at that point. All right, what else do we got? So if we take a look at this one, we want the limit as it goes to -1 from the negative. So I'm going to come from this side. I'm coming from this side until I get to -1. So being the graph exists as I come up and then come back down, the limit coming from the left is at +1. If I come from the positive side, the limit comes down this graph and it gets to -2. So the two limits exist for 4 and 5 because they're directional. So this gave me +1. This one gave me -2. This limit does not exist because if I came from the left, I got to a different y value than when I came from the right. So it's okay if you come from the right or the left. It gets to 2 different values, but you can't say that the limit at x as it approaches -1 does exist. Is that okay? Do you remember that? Remember we did this? I know it was like 2 weeks ago. All right, so then as the limit approaches 0, I get to right here, which is -1. If I come from the positive side, I get to -1 because I'm just getting to right here. The limit does indeed exist to be -1 there because as I came on the graph from the left and to the right, I got to the exact same location. And then what is the limit as we approach 3? Okay. The limit as I approach 3 does not exist because if I come from the left, I get to 2. If I come from the right, I get to 3. So this one does not exist. And then as my limit goes to -infinity, so as I go out this way forever, it appears that our graph is going downward forever. So this is also going to -infinity. All right, do you remember us working on that stuff? Do you recall this? Made sense at some point 2 weeks ago. Okay, may I move up the screen? Good? Yay. All right. So we want to say, hey, if we're approaching from -1 on this graph, from the left, from the right, and from both sides. Okay. This is a little goofy. If I come from, let's see if we can follow this. You know what? I'm not going to put this on the test. So that's it. I'm not going to do the piecewise on the test. All right, but you could come to these. So what's the easiest way to do each of these problems? That's most. Okay. Some of them you can directly plug into. some of you can't plug directly into because you get a 0 in the denominator. So why don't you guys give me until 9:42, so 6 minutes, and try A through H. See if you can figure those out on your own real quick. And then we'll go over them. Cool? Those. Does that make sense? And then let's turn this one off. We'll come to this one. Looks like a straight line. There is a hole on this one. But we're trying to get to x squared minus 9. We're trying to get to 5. So 5 is like right here. Am I looking at that right? X squared minus 9. I'm trying to get to 5. So if I come from the left or the right, I get to 2. So my limit there is 2. Go to the fourth one. Fourth one, we're trying to get to -2. So -2 right here. So where do you think this -2 is going to get to? Like I can't get to -2. So where's my graph going to go eventually? So if I come from the left, I go to infinity. If I come from the right, I go to -infinity. So what can you tell me about this graph? So right exactly here, right there at that 2, as I come this way, this shoots up to go to infinity. As I come this way, it shoots down to go to -infinity. What's the limit? Infinity, -infinity. 2 different directions, right? Does the limit exist? No. So this limit doesn't exist on this particular one, so that would be a DNE or nope or or don't think so or something like that. Then we get to this weird looking one. This is, we want to go, hey, as it goes to infinity, so as I go this way out forever and ever and ever, what am I going to approach? And you might have to like kind of scroll out and see, what does this really seem to be doing? And then as you get out here, it's like 4.7, 4.8, 4.9. So what do you think this limit is? 5, yeah. Okay. And then this one. Did we just do this one? Or does it just look similar? Okay. So we want to know, as this is going to -infinity, where does this appear to be going? Get real close to which y value? What's this line going to be? 0, yeah. So the limit as I go to -infinity is going to go to 0, which is great. Uh-oh, people throwing stuff around again. And then, let's see, x squared plus 2x. So as this is going to infinity, so as I continue to go to the right in the x direction, where is this graph going to go, you think? What's way up that way? Infinity, yep. It's kind of a wild looking graph. And then the last one on that is the line. Hey, if I continue going this way forever, where's my line going to? It's going up, so it must be infinity. Cool. Questions about those? And again, Desmos works very well. I would imagine between all of your collective thoughts, you would be able to handle this type of thing on a test or a quiz. Agree? Go back where? The first one? This one here? Was that the first one? Oh, on the actual page itself. Not Desmos, but the... Nope. Where? Up here? Like here? You good? All right. Let's head down here. Now they want us to find the derivative of each. So h prime, I'll bring the 20 down front. What is 20 times 12? 240. So I get 240x to the 19th because I lower the exponent, plus 80x to the 9th, minus 14x to the 6th, plus 17. And that's the derivative. That's all we had to do is just do the derivative. For number 13, bring the 3 down front, so you get 1/3 of 3, which is 1. So this becomes x squared minus 6x minus 16. And then I have to realize this last part here is 4x to the negative 2. So that's going to give me negative 8. If I bring this down, subtract 1, so I'll get x to the negative 3. So that's going to move back down here. So that's the whole derivative there. What do I need to do to number 14 to make it good? X to the what? I heard it. I thought x raised to what power is the square root? 1/2. Take the derivative. Half of 4 is 2. X, subtract 1 from this. 1's the same thing as 2 over 2. So I get to that to the negative 1/2. You cleaned it up a little bit. You can make it look like this. 2 over square root of x, because the x would move down because it's negative. So the 1/2 power is the square root. Ooh, someone's getting mad at somebody on a phone call. All right, for number 15, I have not taught you something called the product rule yet. So we can't use the product rule. So what we have to do is we have to FOIL it out. So I'm going to get x to the 3rd minus 2x squared plus 3x squared minus 6x, combine like terms. Take the derivative of that, so I'm going to get 3x plus 2x, or 3x squared plus 2x minus 6. And 16 we're not going to do because I have not taught you the quotient rule yet. But there are rules that go along with derivatives that are pretty helpful. Questions about anything we did? You feel confident as a class that you would be able to handle a quiz that did this kind of stuff on Schoology? I think so. I hope so. All right. So it's 9:51. What time are we out of here? 06? Cool. All right. So I want to start a couple of these problems. These will not be on the quiz, but I want to just start them just so you can get an idea of how we would start manifesting derivatives. I have to look at my book, so I always forget things. Let's see, quotient rule. Six, 8, 6. Sweet. All right. So the first thing I want to talk to you about is something called the quotient rule. I just mentioned it. It will not be on your test. Okay. I'm actually going to go back to this. Go back to Smartboard. So this somewhere. Watch where I write first and then make it so you can put it in simpler terms. Where did it just go? Quotient rule. Okay, so the quotient rule to take a derivative takes place when you have a problem like this. X squared minus 4x. Over x plus 5. So it's called the quotient rule because it means you have a fraction, and your fraction has a variable on the top and on the bottom. Okay? So the quotient rule basically takes place in this way. Let's say f of x equals a over b, where a is a whole polynomial, b is a whole polynomial. Still follow me in the conversation? Boy, my eyes stink these days. Probably because I put hand sanitizer on them. All right, so the quotient rule goes as this. You're going to take the bottom times the derivative of the top minus the top times the derivative of the bottom, and then it'll be the entire bottom squared. Okay? Now, let's apply that to what we just did. As far as this problem goes, this is A, this is B. Agreed? Okay, so I'm going to take B. If I want to find my derivative, I'm going to take B, which is the bottom, which is just x plus 5, times the derivative of A. The derivative of A is going to give me 2x minus 4. Do you see what I just did so far? So I'm saying that this top is A, this bottom is B. So I'm going to take B, the bottom, x plus 5. I'm going to multiply times the derivative of the top, which is 2x minus 4. Okay? Then there's a subtraction sign. And I'm going to take the A value, which is x squared plus 4x, or minus 4x, times the derivative of the bottom. The derivative of the bottom is just 1. And then I divide it by the entire denominator squared. So that's the derivative that is not cleaned up. But the quotient rule is a way that you can do the derivative. You know, if you were in a calculus class, they would expect that you memorize the quotient rule. There's all types of little mnemonics. Some of the people go high d low and minus low d high over low d squared or something like that. I mean, I've heard all kinds of weird terms that they use for this. Are they helpful? I mean, the main way is, the nice thing is in here, you get to utilize each other. The hard thing is if you do take calculus later, it becomes a little tougher. So I'm going to FOIL this out. It's going to get me x squared, 2x squared, minus 4x plus 10x minus 20. I'm going to distribute negative 1 over that, so I get minus x squared plus 4x. And then the bottom is going to be x plus 5 times x plus 5, which is x squared plus 5x plus 25. And start cleaning it up. Combine like terms. If I combine those together, I get x squared. If I combine this and this and this, those cancel each other out, so plus 10x, and then minus 20, all over x squared plus 10x plus 25. And this is the derivative of that particular function. That's where we will start working on a little bit more. Let's see. So next week, Monday, we'll work on this a little bit more. Tuesday is a burn day because you have the assembly. Like, we don't have class really. Wednesday, we'll do the quiz on Schoology on this stuff. Thursday, we will work more with this stuff, and then Friday will be another real life application. Are we good? Did I hurt your brains at all? You good? And there are other derivative rules that we will, start covering, but